Hello everyone, this is Bill. We're back to the CompTIA IT Fundamentals Certification course, Chapter 6 of our book. In Chapter 6, we cover the setup and configuration of a PC. In this chapter, it would be best to cover it with a brand new PC. That said, I don't have a new system to go through. Also, the exam won't actually cover setting up a PC in the way this chapter covers it. You will have to know how to plug in cables. You'll have to know what cables go to what ports. And I'm going to do that in a little bit different way in a future video, not in this video. But I will cover that in what I would expect on the exam. What I will cover in Chapter 6 is your power conditions, proper environmental conditions, electrostatic discharge or ESD, electromagnetic interference or EMI, your base operating system setup, and patching. In your operating environment, this is what the system is going to be operating in. It's best to ensure that the PC has proper temperature, airflow, and power. A PC will operate and have its longest life at temperatures at 75 degrees or less. If the PC gets too hot, the heat can damage internal components and they just won't run right. A PC can operate above 75, but it just won't last as long. I mean, I've seen PCs run at 80 and 85 degrees for a year or two without a problem. 3 to 4 years, you start getting weird problems you just can't quite identify. If you do need to run a PC or a laptop above 85 degrees for a long period of time, you can purchase a PC to design to work in adverse conditions. Airflow is one of the environmental conditions we really want to talk about after temperature. Airflow is important to help keep internal components cool. So basically, you've got your system, the outside air is sucked into the case of the chassis. That air is blown over the heat-sensitive components like memory and CPU, and the hotter air is expelled out of the system. So it's best to have a really good airflow within the system. It's also nice to keep a PC in a relatively dust-free environment. That can be difficult at times, but keep in mind that air that's flowing through the system, if it's got a lot of dust in it, some of that dust is going to settle on those internal components, and that may result in an overheating situation. If you do have to operate a PC or a laptop in a dusty environment, schedule a periodic time, once, twice a year, when you can get there and vacuum off those vents. If it's a desktop PC, you can probably open it and clean out the inside of the system and allow the proper airflow of the system. Most of our desktops and laptops are designed to run at 110 volts AC. This is what's common in the United States in our homes and offices. Some servers do have a higher power requirement, and some gaming systems might even have a higher power requirement. So check for those power specifications if you can use a server or high-end gaming computer. If you need additional outlets, you're in an office, you need additional outlets, only have 2. You can use a power strip to provide that power. Make sure it's a UL rated power strip to add that capacity. So again, you might have multiple monitors, an inkjet printer, and a laptop or a desktop all in one area. Again, a UL rated power strip will work just fine. When choosing a power strip, the outlets are the 3-pronged outlets that we see in our standard homes. That's called a NEMA 515 outlet. Again, a server might use something a little bit different. So just, again, check with the manufacturer to make sure that NEMA 515 is what you're going to be using if you have a server. If you travel to a different country, you might need a power converter for your laptop. When we have power problems, there are 4 conditions that we're actually talking about. A power spike, a power surge, a power sag, or a brownout. A power spike is a very brief increase in voltage from the electrical outlet that can last for about a nanosecond or so. It's a very, very short period of time. A power surge, again, is an increase in voltage that lasts for 3 nanoseconds or longer. So it again, it can be very brief, 3 nanoseconds, or it can go substantially longer than that. Power spikes and surges can damage your computer equipment if that increase is large. A lightning strike near a home can cause a voltage spike of up to 6,000 volts. So these can be quite damaging to the system. A power sag, these are really common in the U.S., and that's again a very small, short duration, temporary drop in voltage of 10% or more. A brownout's a longer term voltage drop that can last for several minutes or even hours, and a blackout's a complete loss of power. So when it comes to power problems and how to protect against those, we're going to start with how to protect against our spikes and surges. The power surge suppressors, they can protect against surges and spikes. Read the specifications of these surge suppressors you're going to buy. Remember, a power spike will only last a nanosecond. So you want to make sure the surge suppressor can handle the short duration that spike's going to hit in. You also want to see how much power it can handle. Surge suppressors are rated in joules, and if you're going to get a surge suppressor for a laptop or a PC, try to pick one that will handle at least 1,000 joules for a system. If you have more than just a PC and a couple monitors, you can probably increase that, but you want it to at least handle 1,000 joules for a standard PC. Power conditioners, or line conditioners they are called, can protect against power spikes, surges, sags, and brownouts. The feature that protects against brownouts is called the automatic voltage regulation, and it's not found in all power conditioners. So if protecting against brownouts is important, look for that feature. An uninterruptible power supply, or UPS, can protect against all of our power conditions, including blackouts. UPS is a battery that can power all the equipment except for laser printers. Never plug a laser printer into a UPS unless the UPS is rated for a laser printer. A UPS will last a finite period of time, 20 minutes or less, in a blackout situation. A lot of times UPS will have a USB cable you can plug from the UPS into your PC and run a piece of software, and as the UPS gets its power drops lower and lower and it's about to lose power altogether, it will actually power down your PC to prevent any damage. Again, don't plug a laser printer into UPS. UPSs are not rated for these lasers. These lasers pull a lot more power than an inkjet printer, monitors, or PC. Another power problem we have is electrostatic discharge, and this is the really sudden flow of electricity between two objects that have different charges. That's a semi-scientific explanation of it. Think about this when you're walking across a carpet and you reach to turn on a light switch. Sometimes you get that arc, especially in a dry day, and that arc is that electrostatic discharge. So that charge, if it happens on a PC, can damage components within a computer. These components within a computer are designed to work at 3 and 12 volts. The electrostatic discharge can carry up to 15,000 volts, and that can damage the computer. So how do you protect yourself against ESD? First, you can ground yourself. So before you work on a computer, touch something metal that is near you, like a light switch, and discharge that electricity. I always use an anti-static wrist strap when I'm working on a PC, especially memory or CPU. Don't touch the metal pins or circuits on components on the system when you open it up. So if you're handling memory, handle it by the sides, not the connections. Try to work in a humid environment. 25 to 30% humidity. If you're in a data center, data centers are usually operating in the 20 or 25% humidity range. And then you can use anti-static mats, and if you ship devices or carry devices from one location to another, use anti-static bags. Electromagnetic interference occurs when data that's being transmitted is interfered with by an outside source. So outside source could be fluorescent lights, microwaves, or some other source that emits electromagnetic radiation. So again, you're sending data across a wire, and it passes by this electronic EMI source, and that ends up with corrupted data. EMI can also affect wireless signals, so just keep that in mind. Common sources of EMI are fluorescent lights, microwaves, and electric motors. So going back to the wireless discussion, if you have a laptop and between you and your wireless access point or your wireless router is, say, a microwave, if you're getting some weird results, slow performance, kind of weird data at your laptop, take the laptop and move it away so the microwave is not between the laptop and the wireless access point, and see if that corrects the problem. If that does correct the problem, you're having a problem with that microwave, and that microwave is either leaking too much radiation or it's just the point where it's in the wrong location. You may have to move it. To protect against the EMI, if we're in a cabling situation, run these cables away from your sources. So don't run cables over, say, fluorescent lights or under motors. Try to get those cables away from them. If you can't get away from the EMI source, use shielded copper cables for your data. If that still doesn't work, if it's a really strong EMI source, you may have to replace copper cables with fiber optic cables. That's a last resort. When it comes to setting up a computer for the first time, so you just get it from the store, you unpack it, put it on your desk, you got all your cables plugged in, power it on, setup program is going to run. That setup is designed to install the operating system for your desktop or your laptop. Servers can be a little bit different, and we're not going to cover server operating installs in this certification. When you configure an operating system, you're going to have to configure the following. You want your local time and time zone, daylight savings time, that's a yes or a no question usually, the country where it's located. The operating system itself is going to detect your screen and the resolution. You'll have to know that those are correct. Usually they are. Verify the operating system detects your audio for the computer, so it'll verify the speakers if you have them and a microphone. The OS will then look for your internet connection. Again, you may have some configuration here, but most systems don't have much of a configuration. If it's a Wi-Fi system, it'll see the Wi-Fi. Make sure you pick the correct Wi-Fi SSID. That's the Wi-Fi name. You may have to enter in a password to get onto the system, and then you're going to be on. If you want to, you can skip that and come back to it later. Most operating systems will require you to enter a default user account, and that default user account is going to be an administrative account. So be sure to select a strong password for this account. Try to have it mixed case, upper lower, so it's upper lower case, numbers and a couple symbols, and try to make it long, 15 characters or longer. After the computer operating system is configured, so you've got, you're now sitting at the computer, the system may again have to connect to your wireless or to your wired network. If you're using a Wi-Fi, try to verify that it's using WPA2 or WPA3. Anything less than that, WPA, WEP, has been broken, and you're going to want to upgrade your wireless to something stronger. Turn off your file and print sharing. Install your security software, antivirus and firewall. If by default, if you're running Windows, the Windows antivirus and Windows firewall are also turned on. If you're using a different antivirus, you may have to install that. Run the operating system updates, and to do that in the Windows environment, you're going to click on the Windows tab, search for update, and then click on the update, and then check for updates. On a Mac, open the App Store and check for updates. Next, you want to add and configure printers. Add and configure any new input devices like touchpads, trackballs, anything that's new. Configuring these, if they're USB, is really simple. You simply plug them in. USB kind of configures everything for you. If it's brand new and the operating system doesn't recognize what you have, you might have to download drivers and get those installed manually. You want to remove unnecessary or unneeded software. A lot of these new systems come with trial versions of antivirus software, Office software, games. Remove these, following the proper documented procedure. Be careful when removing security software like antivirus software. Verify the uninstall procedure for those. Sometimes if you go through the operating system, in Windows is add or remove programs, and click on uninstall, some of these antivirus softwares will do things like disable your wired or your networking. If that does happen, you'll have to reinstall the software and then go through the proper procedures to remove the software. So again, you'll want to find out what procedure is necessary to remove that software. If you are going to install any new software, add that. You'll want to create some new accounts to ensure that these new accounts don't have administrator rights. Be sure you keep that administrator account that was created when the operating system was installed. Be sure you have that username and password stored away, because you're going to need that in the future to do troubleshooting. That is it for Chapter 6. Chapter 7 is mobile devices, phones, and tablets. And talk to you later. Thank you.